Just well, hi everybody. Lex Dillon, retired tomato grower. Been involved in this research project that we've had between Tomatoes New Zealand and A Lighter Touch for about the last 4.5 years. I think it's been going. Finished in March. And really just what the tomato industry's approach towards TPP and Liberibacter has been. So Tomatoes New Zealand and A Lighter Touch initially established this research project to test whether Engitatus nicotini could effectively control TPP in commercial glasshouses. There'd been some initial research carried out at Lincoln University by Emiliano Veronesi and the plant protection team, and Engitatus showed some real promise in lab situations in controlling psyllids. And what we wanted to do was to try and expand that out into some commercial applications to see whether that lab work could be expanded and be good for growers. So the goal being is if you can control TPP, you can control Liberibacter. In 2022, the project morphed a bit into a more general biocontrol project where Engitatus was one of 5 beneficial insects that we were using to combine both TPP and greenhouse white. Okay. Okay, there were 7, so this trial took place with 7 trial sites throughout the North and the South Island. Growers participating in the trials ranged from small family-run businesses of couple thousand square metres to commercial sites, some of them as large as 5 hectares in size. And that's quite important because you've got to have a look at the different abilities to access resources that different growing businesses have. The larger commercial operations have full-time pest counts. The smaller mum and dad businesses, it tends to be done by mum and dad and maybe there 1 or 2 staff members as they go through the crop and do their work. Some of the data collected through this trials was statistically valid and other was more observational. It was way harder to get the statistically valid data from mum and dad than it was to our big commercial operations. Okay, was using Engitatus effective at eliminating Liberibacter? No, a resounding no. But it did reduce the amount detected, and the process highlighted the presence of TPP at very early stages. So why wasn't Engitatus effective in controlling Liberibacter? Well, using BCAs or biologicals to control the pest in your crop is not about having 0 in the crop. It's actually about maintaining the pest levels at such a level that it's economic for the growers to be able to produce the crop. It's about managing, as I said, so Engitatus assisted the growers to reduce the TP populations in the glasshouse, but it didn't completely eliminate them. If any TPP entered the glasshouse, there was always the risk that Liberibacter, and this proved to be the case with our experience. And sitting here today and hearing about how that TPP can be in the glasshouse for 5 minutes and Liberibacter can be transmitted explains that. So there were some positives and learnings. Engitatus was trialled as a TP defence mechanism in tomato crops. So the process of the way that the tomato growers were handling this was kind of like an insurance policy or a guard dog approach. So the idea was to establish Engitatus populations in the crop prior to any potential incursions. So banker plants, tobacco, were introduced at the time of planting, and Engitatus can survive upon tobacco plants without pest back present. The banker plants developed breeding populations of Engitatus to potentially intercept any of the TPP incursions. We did have, whilst we did have some TP incursions, they were manageable. We found Liberia-infected tomato plants without finding any TPP in any stages of the life cycles in some case. And this kind of suggested that maybe TPP had been present but had been predated upon after infecting the plants. A bonus was that Engitatus also feeds upon greenhouse whitefly, and for tomato growers, whitefly is actually more of a problem in our glass houses than GDP is. More learnings. The project reinforced that effective crop scouting is essential for basic biological control systems, right? And there's one thing that's very clear in my mind in this whole process that we've had in this biocontrol project is that scouting is the key to it. The good news about tomato glass houses is mostly workers and scouts are going up and down rows every day. Okay, you're picking in the summer 3 times a week, so you've got pickers going down the rows. They're going down doing jobs like twisting and pruning and delateraling and all those things. So you've got people going up and down the rows all the time. So it's not just about having dedicated people doing scouting work. It's actually also about training all your staff up so that they understand and can and identify the symptoms of any pests and diseases in the glasshouses as they're doing the work. Tomato plants showing Liberibacter symptoms are removed and bagged. Actually, I should have, when I was looking at this morning, they're actually bagged and like you pull them out and bag them in the glasshouse before you remove them out of the glasshouses. One of the interesting questions, and I know it came from the tomato grower when we talked to you before, Jessica, is about mechanical spreading. There's a train of thought that maybe Liberibacter can be mechanically spread. The reason being is in tomato glass houses, where we find infected plants, you tend to get other infected plants further down the same row. If you've got no TPP in the glasshouse, what's causing that? No Liberibacter in the glasshouse. What's causing that spread? And why is it going down? Why is it just going the same direction down the road and not before the infected plants? So, no answers, but just like all research, more questions. So, would be something that the growers are asking our industry is maybe that's something we'd have a look at and see whether that could be done. There's been a whole heap of learnings from this whole process. And one of the things that we've done as a result of these trials is developed a whole heap of resources that we can share with our growers. One of the first things that we did was this, an integrated pest management guide for our growers. And this has got things in it like, and this is for all glasshouse pests, but like a whitefly decision-making tree. If you're scouting for whitefly, find whitefly, what processes should you go through? There's a whole lot of pest sheets and action cards. Again, this is that's for psyllids. This is what they look like. This is their lifestyle. From egg to egg, how long that takes, potential control measures, scouting tips, what to do, just a few, doing damage, ongoing issue, those sorts of things. And we've done that for psyllids, for aphids, for scarab flies, for russet mite, all those sorts of things. So we're developing resources for our growers. The other thing that we look at is decision trees. So the guide is a living document and that's being updated all the time. And I was interested to hear your comments about spraying and the effectiveness of spraying. And one of the things that we identified in the tomato industry is that some of our growers weren't spraying properly and didn't know how to calibrate. So we've run workshops and we've also got another edition going through this guide on the basics of spraying and how to set your sprayers up to get the most effective coverage. There's been a series of helpful video guides being developed. Can we play that one that we've got? Can't do it? No, we just talk about it. Okay, so there's been a series of video guides developed, and one of those, in fact, is on banker plants in glass houses, how to set banker plants up to breed your Endurtatus populations to help control your TB, where to locate them, all those sorts of things. So that's just part of the resources. And this has Engitatus and banker plants is one of those. We've been a number of articles regularly appearing in industry publications, and there's also been a number of workshops specifically to cover these things for tomato growers throughout the place. We're doing a number of presentations. This is over the length of the project. I don't know, this is my 5th or 6th, and there's another couple to go before we wind it up in a couple of months' time. But we're putting a lot of effort into sharing the learnings that we're having with our growers. In summary, so Engitatus can help suppress TPP, but there does remain a risk of Liberibacter infecting the plants. It plays a supportive role in managing greenhouse whitefly, which is, as I said, our tomato growers' main pest. Growers saw significant gains through using IPA pen-based systems rather than traditional chemical control. Part of that is because that chemical control in glasshouses is generally what's nowhere near as effective as it was. And just like you guys, there's nothing or very little new coming onto the market. So it's a matter of having to get this to work rather than wanting to get it to work. The growers made gains in both efficacy and also they got better returns for their crops. So I guess at the end of the day, that's what we all want to achieve. Sorry, where's that one gone? So just some acknowledgements. Tomatoes New Zealand, a lighter touch. They've supported this project right from the beginning. Emiliano and the people at Lincoln did some amazing work at the beginning to allow us to build on that. Bioforce, thanks guys for providing us some managing the project for us and also providing the beasts to do the job. And the growers, as always, without growers participating in these trials, we'd go nowhere. And I see we've got some TNG covered crops people here today, and they did an amazing job on this project. So thanks very much to you all. That's me, Eddie. Short and sweet, hopefully.
Thanks, Lex. Is there any questions for Lex?
I love the question, but I mean, the common theme seems to be with that fast transmission of Liberibacter, there's just no way that it's not a risk. Right? Like, I mean, with
that's why I say you just always end up with Liberibacter with separate in the case of potatoes, because you can, and even in tomatoes, I know it's covered, you know, there's maybe it's more intensely managed, but you just can't beat that. You know, you can't be everywhere at the same time and see if they're feeding or not.
Yeah.
So, and the BCAs are too slow. Well, we know that, but they're just too slow. But the same as a systemic insecticide could be too slow, or a compact insecticide is too slow.
So the silver bullet would have to be some kind of repellency type component, right?
Yeah.
So the silver bullet would have to be some kind of repellency, right?
Yeah,
To
or
deter them or to pull them away in some other.
As I say, the other advantage, I guess, that tomato growers have is we've got people going up and down those rows every day. And best practice in the industry is, you know, if in doubt, pull it out, right? So, you know, if you see something that's suspicious and the very earliest stages of a Liberibacter infection, if you can see a plant starting to go yellow or leaves curling up, that sort of thing, most of our pest scouts are well trained to know what that is. And so those plants get pulled out, whether it's Liberibacter that's caused that or something else. We find out what it is that's causing it after we've taken the plants out and pulled them away. So I was around in 2006 when we had the initial incursions, and the big issue we had then was we didn't know what it was. So we had all this damage happening around us and losing plants and losing crops, and that's when crops were lost. A little bit like the comment you made about potatoes, if it wasn't for the Liberibacter, psyllids wouldn't actually be a huge problem in tomato glasshouses.
I think not disappointing thing, I think the thing that we were hoping we'd get out of the CPLI was the fact that we'd be able to identify some sort of a lure. You know, that would have been...
Which was a big project looking for that, but they just weren't able to identify anything that was...
Lex, Okay.
You go first, please.
You say that it's an advantage that, people go up and down the road
Yes.
every day in greenhouses. For me, I see that as a big risk as well,
Yes.
because these insects are very small. And you are disturbing the plant with
Yes.
some of the work that you're doing, which means that you're disturbing the psyllids and they could quite easily jump to the next plant or within the row. And so I think that's, I don't want to say that you're wrong with your mechanical training method, but spreading down the row, the first thing that comes up in my mind is that people spread or machines spread, basically, that you disturb the insect and or you have it on your clothes, you go to the next plant and it jumps off.
I guess the issue that we have with that is that we're not finding any psyllids. We're not actually finding any of them in the crops at that time.
When you say it's down the road, is that running in the direction?
So you're all in tomato glasshouses, you always work up and down the roads, because there are other diseases that are mechanically spread, right? So by doing that, you can follow the train of what's happening in the glasshouse.
The library backer spread was unanimously in the direction of the knife, even though the people travel both ways.
Right.
Hence the
Okay.
It kind of reminds me, I mean, PVY, potato virus Y, always used to be considered as an aphid-only transmitted disease until the work of John Fletcher. And now it's fully recognised as being contact transmitted as well. So it may be.
Means that potato industry would cut seed will have
Yeah,
an issue.
absolutely. Absolutely.
I think it's definitely worth looking into.
What?
I have never heard that, and from what benefit in the initial day.
No, I haven't either, no.
that,
Yeah.
it is transmitted.
On that point, we are actually now testing seed lines to see whether they contain very low levels of Liberibacter. We've just collected a whole series of seed lines and we're going to PCR test them and see whether there's Liberibacter in those seed lines at a level that we can't see in the plant.
It makes
It's
sense.
interesting.
Like a knife going down, the time from plant to plant to plant would be tiny, right? You're going to think that sap from that plant surely has to. I don't know. It makes sense, but the science.
How good was your anti-tatus outside? Like, could you actually use it in potatoes?
Sorry, can I pass that one to Chris? He could probably answer that better than I.
Just have to plant sort of that would be the most wise plant around your headlands or something like that, because that will attract them.
I think we did try
Yeah,
anti-tatus.
there were five benefits used.
And it wasn't all that effective. It wasn't one of the most effective.
That was released in the box store.
The box zone, that's right. Yes. Yeah. I mean, the most effective was the brown lacewing collection,
Which we get maximum.
which you get lots of.
And there'd be other issues with having tobacco around.
Well, there is even in tomato glasshouses too. So there is some work being done on an alternative to tobacco. Am I right, Chris? Yeah.
What were the other predators? You said you expanded the numbers. What were
So
Oh, yes.
Yeah.
Tasmania. It was actually the two programs went in parallel.
Right.
So Tamaraxia was used in conjunction, but it's pretty slow. It doesn't stand there as a standing guard like Injitalis could.
What?
So,
Lincoln University found was that combinations work better than the individuals who seem to have an additive effect.
Many years ago, we had a British IBM expert come out and speak at our conference one time, and he said they've got some beneficials they use that are only 10 or 15% effective, but it's the 10 or 15% that breaks the camel's back.
Yeah.
And so that's why having sweets, what we've found with the controlling our white fly primarily, but also with TPP, is that having a number of beneficials working together in the glasshouse, in combined with soap sprays and oils and soft chemicals, is the way to go. It's not when I say that we've got these BCA or biocontrol projects working successfully, it also has the soap sprays and things like that as part of it, very much so.
Like anything, right? It's an integrated pest management
Yeah.
program. It's not putting all your eggs in one basket and thinking it's the crop health, it's the beneficials.
The other thing about the attention, the attention to detail that you need to do to make this work is quite a bit, and people have to be committed to it. And what we have found at different times is growers have given it a go, and then got into it and that, and they get a bit of a build up or something, and they lose their nerve. But we also had another situation where a glasshouse was completely out of control using chemical sprays, and the grower his only option was to stop sprays, start stoke, put beneficials in. Took him 10 or 12 weeks. It was like chalk and cheese. Got the crop back under control and saved the crop that was going to be lost into one that was actually didn't have a great year, but actually finished off and finished off with a healthiest crop, producing crop. Yeah.
It's also worth mentioning from Potatoes New Zealand perspective, we're starting to engage with some of the other Liberibacter zebra chip projects around the world. There's a big one that's going on in Europe right now, Patafest, which we're now engaging with. We met with them the other day, and we're about to engage with the project in America and the States. Texas, I think it is. So we're about to have a meeting with them. So we're trying to pull the knowledge together from a number of different research projects that are going on around the world.
I recall, it's interesting the comments about increased psyllid issues in Washington State. And we used to deal with tomato growers based in British Columbia, very close to the US border, in the Delta area in Vancouver. And they used to get psyllid issues, but what they found was the winters used to pretty much take them out, and then they would get them because that's where I think our Tamaraxia came from up there, did it? Oh, Mexico, okay. But they used to use Tamaraxia, but the beneficial insect suppliers stopped supplying it because 4 or 5 years of no Tamaraxia, no psyllids, and then they get a really warm season. It almost tracked the climate. These of the warm air going up through the middle of the United States, and then and not being there again. No, actually, just another point about biological control systems. If growers want to do it, they have to commit early, and they have to communicate to everybody that they're dealing with. Their crop advisors. The BCA, the biological breeders. You can't. Hey, I've got a whitefly problem. Can you deliver me a million Incassia or a million Angitatus? You've got to plan what you're doing, and you've got to set it up right from the beginning and have everybody in your circle involved. We've had other instances in tomato crops where one of the growers was going to be part of the trial, got his plants delivered to his glasshouse, unbeknownst to him, the nursery had put a root drench, insecticide root drench through, put the stuff on it, wiped out every beneficial that was on the crop within the first, and took them out basically for the whole season. So that was the one thing about doing projects like this. You just get all these lots of little leads about what you have to do to make it. But hey, we've had some really good successes, and I did some research at the beginning of the project about 4 or 5 years ago. And the uptake of what we're doing now has been, we're well ahead of where we were when we started the project. So at the end of the day, I said to the people, if it's going to be effective and economic for the growers, you actually won't have to do anything because the growers will pick it up. Cheers. That's me. Thank you.
Great. Thank you, Lex. I think that's just about it for us. I just want to thank the 4 speakers. Everyone, please join me with thank